Now that we've learned about percent composition, let's talk about the empirical formula and the molecular formula. So just a couple of definitions. So the molecular formula is probably what you are aware of. It's the exact proportions of atoms present in a molecule, right? So glucose has a molecular formula of C6H12, H12O6. So there are 6 carbons, 12 hydrogens, and 6 oxygens. Now, the empirical formula is the smallest whole number ratio of the subscripts in the molecular formula. So what we would do is we would just try to look at 6, 12, and 6 and try to find the smallest whole number ratio, which means that we're going to divide all of them by 6, okay? And so the empirical formula of glucose is CH2O, because all subscripts of the molecular formula can be divided by 6. Okay, so this is the most boiled down version. This is the actual typical version. So many different molecules can have the same empirical formula. This is basically the root formula. So the reason why we have two different formulas here is because analytical chemists will do what we call combustion analysis. So they'll have some kind of hydrocarbon or something like gasoline or something like that that has carbon, hydrogen, and oxygen in it. And so what they'll do is they'll put it in their sample here, and inside of this tube, and this tube is combusted. So it's heated up until it burns. And so they're continuously supplying oxygen. So oxygen is supplied in excess. And then, well, the products of combustion are always going to be always going to be CO2, and they're always going to be water. So you have one area that will have a water absorber, and so they'll be able to see the change in mass of water, and they'll be able to see the change in mass of carbon dioxide. Well, all of the carbon in the original sample went to carbon dioxide. All of the hydrogens went to the water, okay? And you can't really tell where the oxygen was because oxygen was in excess, but we can figure that out later. So essentially, if you don't really remember that, this is basically what we're doing here. So what this does, though, is it provides an empirical formula for you, okay? So that's why we have these. And then we can figure out the molecular formula. So here we go. To figure out the empirical formula, you'll have a problem here, or they will often give you a percent composition already. You'll assume that the total mass of the sample is 100 grams, which will make your calculations easier. You'll divide by the amount of each element by the molar mass. This will give you the moles of each atom present. Then we'll divide each of the number of moles by the smallest number of moles, and then you should get something that's close to the whole numbers. And these whole numbers are the subscripts of your empirical formula. Simple enough. So let's try it real quick. A hydrocarbon is composed of 85.6% of carbon and 14.4% hydrogen. Find the empirical formula. So it is 85.6 grams of carbon and 14.4 grams of hydrogen. Okay, you see how I took those percentages there, and I just assumed that if it was a 100-gram sample, 85.6% of 100 grams is 85.6 grams. See? Uh, Now, I'll just take those grams and I'll convert them to moles. So I'll take the grams divided by the molar mass of carbon, and I'll get my number of moles of carbon. And then I'll take my mass of hydrogen divided by the molar mass, which is 1 in this case, and get my number of moles here. Well, now I will take the least number of moles, or the smallest answer. I'm going to divide each one of those by the smallest answer. So I'm going to divide 7.13 divided by 7.13 is 1. And then 14.3 divided by 7.13 is approximately 2. Okay, there's a little bit of rounding here, but you should get a whole number. So those are my subscripts. I have 1 carbon, 2 hydrogens. So the empirical formula is CH2. Simple enough. So to find the molecular formula, you have to find the empirical formula first. So the molar mass will have to be given to you, all right, in the problem. Then you'll obtain the empirical formula. Then you'll compute the empirical formula mass, calculate the ratio of molar mass divided by empirical formula mass, and then round this ratio to a whole number. This number is your factor, right? Your end factor. You'll multiply all the subscripts in the empirical formula by that end factor, and that will be your molecular formula. So let's take the previous example. Let's say that had a molar mass of 28.054 grams per mole. Find the molecular formula. So the empirical formula was CH2. Remember that? And so what we're going to do is we're going to find the empirical formula mass. So that's, we'll just take the mass of carbon, right? Just like you're doing a molar mass right here. That carbon is worth 12, and then hydrogen's worth 1. Now there's 2 of them, so you multiply by 2. So now you get 14, okay? That's your empirical formula mass. Then you're going to take your molar mass divided by your empirical formula mass, and that's going to give you 2, or round about 2. You may have to round to a whole number, but it should get pretty close. So that is your end factor. You're going to multiply all subscripts in the empirical formula by 2. So here's your empirical formula. You're going to multiply them all by 2. The 2 distributes. And so your molecular formula is C2H4. Okay, simple enough. So let's try one last one real quick, just as full way through. So to determine the empirical and molecular formulas for a compound that gives the following percentages on analysis in mass percent. 71.65% chlorine, 24.27% carbon, 4.07% hydrogen. The molar mass is known to be 98.96 grams per mole. So we're going to assume a 100-gram sample, which is going to make our calculations easy. We have 71.65 grams of chlorine. That percent just gets changed to grams. And so we'll divide by the molar mass of chlorine from the periodic table, right? And then we'll get the number of moles of chlorine. We'll do the same thing for carbon and same thing for hydrogen. Simple enough. These, again, came from the molar masses. And so now we have all of our moles right here. We're going to pick the smallest one. We're going to divide them all by the smallest one, which in this case is 2, or 2.021. So we get that. And so we have 1 mole of chlorine, 1 mole of carbon for every 2 moles of hydrogen. Those are your subscripts. So the empirical formula is CH2Cl. Now, I get a lot of questions, which one do I put first? The least electronegative one gets named first, so that is always the one on the furthest on the left on the periodic table. With the exception of hydrogen, hydrogen's never on the left. Is typically not written first, unless it's an acid, and that's something else later. Okay, so, but just put carbon first. Carbon is always first. How about that? So the molar mass is known to be 98.6 grams, 96 grams. So we know the empirical formula. We'll find the empirical formula mass just by adding them up from the periodic table again. And so we get 49.477 grams per mole. And so we'll take the molar mass that's given in the problem divided by the empirical formula mass that we just found. We'll get 2. We're going to multiply all subscripts by 2. And so that means that the molecular formula is C2H4Cl2. Simple enough. Have a great day.